Chapter 3.6, exercises 21 through 30. Section 3.6 in the book has to do with mathematics of finance, and particularly these problems here. This problem set has to do with compounding of money. So real big, real world use nowadays. The basic formula we have for accruing interest is this. We have an amount which is equal to a principal, which is a starting amount, times quantity 1 plus R, and R we divide by the compounding, number of times compounding, frequency of compounding, which we call K. Some formulas will say N, to the power of KT. And so this would be, A would be ending amount, this P, which is principal, this is going to be a starting amount. This R would be rate. Okay, rate. And it's not going to be in percentage. It'll be in decimal form. We'll get to that. K we'll call compounding frequency. And then, of course, that would occur two places. K down here and underneath the R, and also up here in the exponent. And T would be time. And time is going to be in years most of the time when it deals with money. So let's go ahead and apply this formula. Erase enough to leave room here. KT. Okay. Now, applying this formula, if John invests $2,300, and so we're going to start with $2,300, and our finishing amount is going to be $4,150, and our formula is going to be 1 plus our rate, and our rate's going to be 9%. That's going to be 0.09 over, we're saying quarterly, so our K is equal to 4. For quarterly, that's how many times per year. So 0.09 over 4 to the power of, well, we have K, which is 4, and then we have T. So just kind of simplifying, we have 1 plus 0.09 divided by 4. So we're going to have 1.0225. So we have $4,150 equals 2,300 times 1.0225 to the power of 4t, and so dividing by 2,300 each side of the equation, we have a cancellation, so we have 1.0225 to the power of 4t is equal to this ratio of 415 over 230. Now where I get 415 over 230, I put this 0 over 0 canceled out. And so when we have a variable up here, we can get this like we have a base to the exponent. So we can change this exponential equation into a logarithmic one. So we can have, I'm going to go up here to the right, up to the right. We have log base 1.0225 of this amount here, which is 415, 415 over 230 equals 4t. And so t is going to be equal to log base 1.0225 of this quantity here, 415 over 230 over 4. And so we go to our calculator. Okay, we go here. Log base 1.0225 of 430, 415, right, over 230. And we're dividing this by 4. So we get 6.63. So 6.631 years. And what's that going to be? We're compounding quarterly, so we're not going to get that additional amount until, we're not going to get some amount in 6.61 years. And that's going to be essentially 6.5 would be this at the second quarter. The third quarter would be 6.75. So we'd say our time we're going to actually need would be 6 years and then 9 months. And why 9 months? Because to get to that third quarter, we're going to have to wait until 9 months to get our third quarter compounding. So 6 years, 9 months. Let's go on to the next odd in our problem, which is 23. Megan is the trust officer for the state. If she invests $15,000 in an account that carries an interest rate of 8% compounded monthly, how long will it be until the account is valued $45,000 for Megan's client? Well, we have the same formula. We have our starting or finishing amount, which we're aiming for, which is $45,000, equals our starting amount, $15,000, times 1 plus, in this case, we have 0.08, and we're compounding monthly, and so the k is going to be 12, so we divide by 12 to the power of 12, and in t, 12t, so we're trying to find time again. Well, it's the same process as before. This time I'm going to divide by 15,000 first. And what we have is, I'm going to put this 1 plus 0.08 over 12. Let's go to the calculator now. 1 plus 0.08 over 12. So we get 1.00667. I think it's going to be 66666 and so on, right? So let's go here. We have 3 equals 1 point, let's see, we have here, yeah, 1.00 0066. I'll put 6667 to the power of 12t. And so what we're going to have is our base of our logarithm is going to be this 1.006667. So we say log base 1.0066667 of 3 is equal to 12t. So t is going to be equal to log base 1.006667 of 3 divided by 12. And so let's go to our calculator. Okay, log 1.00666, we can keep on going out, right? 67 of 3 and divide that by 12. We get 13.78 years. So let's go ahead and write that. 13.78 years. And how many months is that going to be? Well, if we take the 0.78 and multiply that by 12, we get 9.36 months. So to get, if we're compounding monthly, we're going to have to round up the next month. So for this, we're going to have, we'll have t equals 13 years, 10 months. So that's how long we're going to need for Megan's client to achieve that kind of growth at that percentage rate. 25, finding the interest rate. When interest rate compounded daily, which is 365 days per year, is required for a $22,000 investment to grow to $36,500 in 5 years. Same formula. We have our amount, our final amount, which is $36,500, is equal to our initial amount, $22,000, and we have 1 plus R, and R we don't know, R's are unknown here, R over 365 times 365, which is KT, right, times 5. So this 365 times 5, let's look at that. So we're going to have 1,825 days. So we're just going to say here, 1,825 days. So let's divide out by 22,000 first. And so we have one plus R over 365 to the power of 1,825 is equal to 365 divided by 220. Now, what do we get 365 over 220? We just dropped out these zeros here. So just to make our arithmetic a little easier. So now what we're going to do is we're going to take a root. It's like we have to the 1,825 power. So if we take the root of 1,825 and do the same thing on this right side here, take the root of 1,825, we're going to have 1 plus R over 365 equals the 1,825th root of 365 over 220. And then finally, not finally, but if we subtract 1, we're going to go up here. If we subtract 1 from both sides of this equation, we're going to have r over 365 is equal to this 1,825th root of 365 over 220, and that's going to be minus 1. And finally, r is going to be equal to, we cross multiply this 365, so we got 365 times, I'll put the whole thing in parentheses here, the 1,825th root of 365 over 220 minus 1. So let's go ahead and do that in our calculator. We have 365 times, open parentheses, we'll get our division here. We have our root, oops, I got the wrong way here. Let's see, there we go. The root, 1,825, fifth root of, we get this 365 divided by 220. Let's make sure I get this right here. And we have minus 1. So we don't need all that. We don't really need all this. We'll just say divided by 1 here, since that'll make it easier. And then here we have, what is that again? Minus 1. So we'll put minus 1. And that should get it right there. Enter, we get 0.101268. And so in percentage, R is going to be equal to 10. It's equal to 10.127%. Okay, next on our problem 27. Jackson actuary working for a corporate pension fund. He needs to have 14.6 million grow to $22 million in 6 years. What interest rate compounded annually does he need for this investment? Similar to the last problem. I'm going to set this up and take a bit of a shortcut. Okay, if we want to grow to 14.6 million, or actually, no, we don't want to do that. We want to grow it to 22 million from 14.6. And we're going to have 1 plus R, and we're compounded annually, so K is 1. And we're going to the power of 6 right here. So we would have and notice I put 22 instead of 22 million, 14.6 instead of 14 million. I realize in solving, we're going to divide one by the other. So the amount of money does not make a difference, right? As long as the respective numbers are right. It could be 14.6 cents growing to 22 cents in 6 years. So the amount of millions is not important. And what we can do with something like this is a lot of your calculators have something, have a equation solving type of function. And in our calculator here, our TI Inspire calculator is called NSolve for numerical solve. So we're going to use that device here. So we're going to go to Menu, Algebra, and we're going to go to Numerical Solve. And our equation is 22, representing 22 million, equals 14.6, representing 14.6 million, times, we have open parentheses, 1 plus R, which I'm going to say is X, to the power of 6, and then we're going to press comma, X, and we're going to get a number here, which is 0.070726. So R is equal to 0.070726. And in percentage, we'd say R is approximately equal to 7.073%. So that would be using numerical solve. This has been particularly helpful back earlier, like problem 23. Next problem, doubling your money. Determine how much time is required for investment to double in value if the interest is earned at the rate of 5.75% compounded quarterly. Well, again, using our formula, and we're interested in doubling, so we'll say double is 2, and our starting amount is 1, right? If we double, we could use $1. How long does it take for $1 to become $2? 1 cent become 2 cents. So, and we are compounding quarterly, so we're going to have 1 plus 0.0575 over 4 to the power of 4 times t. So we're going to go, we could go ahead and divide by 1. We would have, we would work it all out, but I'm going to go to numerical solve again on this one. I'm going to put numerical solve, just algebra. We're going to have 2 is equal to, I'll just put 1 times, open parentheses, 1 plus, we'll get our division bar here. We're going to have X over 4 to the power of, we'll say 4x, right? How long will it take? Let me see, hang on. We're interested in this here, 5. Oh, excuse me. Look back here. 0.05 575. There we go. And this raised to the power of 4 times x. And we should get the amount of time it takes to make sure everything's in the right place. Go to our thing here. 4t. Yeah, it should be right. Okay, press enter. And we don't get it because, what did we not do? Didn't press the comma and the X. There we go. And that amount of time is going to be 12.14 years. That's all it's going to take. And what that's going to be is compounding quarterly, it's going to be 12 years. And we're going to have to wait for that whole quarter to come about. So that's going to be 12 years and 3 months. So these are the odd number problems worked out in this set. Good luck as a demonstration for learning on the even number problems, and thank you for viewing.